Welcome back, stats, to another exciting lesson. This is set notation and Venn diagrams. We're going to skip the bell work for right now and just go straight into it. The objective and essential question. We're going to go to what set notation is, how does it relate to diagrams, and then we're going to be done. Although I do think I have a Desmos activity that kind of piggybacks off of yesterday's lesson, the box plot, the 2.5 measures of position. So we'll probably do that as well. So the majority of the time will be with the set notation in Venn diagrams. So without further ado, let's get started. I will consistently remind you as you're writing this down, the essential question. I will consistently remind you that you ought to be doing Math Excel. You should have the pretest done. You should have the orientation done. You should have the Math Excel login information completed on Google Classroom. Okay, you should have all of that done. All right, you should have the Learn Desmos and Learn Statistics activity from the first video done. Okay, all of that should be completed. You should have the syllabus acknowledgement form done, completed. Okay, if you have yet to do any of that, if you have yet to even be on Math Excel, that's a huge problem, and you probably heard from me earlier this week. Okay, so let's get started. I don't want to waste any more time, but just FYI, you need to be paying attention to these videos. How do I use set notation and Venn diagrams to describe a number of outcomes? Let's find out. So first of all, what is set notation? What are sets? We kind of talked a little bit about them, but not really. So what are sets? The definition is very simple. A set is a collection or groups of elements. This could mean numbers, letters, unicorns, people. I mean, it doesn't really matter. It's just a set of things. It's a number of things. It's a group or collection of things. A group of comic books could be a set. My calculators in the classroom could be a set. My library in the books, a specific section perhaps, could be a set of books. All right? What is then set notation? It is usually named using capital letters, so set A or set B, and it looks something like this. It looks scary, but it's actually not. It's very simple to understand. Set A equals braces. This is what a brace is, this little squiggly thing, a brace, X, such that, that's what that means, X is an integer where X is between 1 and 9. So I'll read it again in English because this is the math. Math is a language. We need to understand the language of math, but we also need to look at the English side of things. So this is the language of math, and I'm going to read it as I follow my cursor. That's what what I'm speaking is what it corresponds to in mathematical language. So set A is the set, the braces, the set of all X such that X is an integer where, that's the comma, where X is between 1 and 9. That's what that means. So let's start looking at it more closely. There are three ways to do a set. First of all, there's a descriptive sort of way. So if I say the set of integers between 1 and 10 inclusive, okay, I can say the set of whole numbers greater than 5. That's what that means. Kind of basically me reading the English. That's what description means. Okay? There's also another way, the roster form. The roster form is, well, just listed them out. I can list 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. Okay, so, and I actually forgot 10 here. This is supposed to be 10 right here. So this A corresponds to that A. So the set of integers between 1 and 10 inclusive also includes this. Actually, let me just finish that. All right, I just fixed it for you. And then B right here, B is greater than 5, but it's not equal to 5. So I have 6, 7, 8, and then I'll go 9, 10, 11, 12, so on forever. So, like I said, this A corresponds to that A, okay? And then this B corresponds to that B. Perfect. What is set builder notation? Set builder notation is probably the most complicated one, but it looks a little bit more fancy. Okay, so it is literally what I just showed you in the last slide. So the set of all x such that, that vertical line, x is an integer where 1 and 10 are the outside bounds, and in between x is residing. So where x is between 1 and 10. So again, this a corresponds to all the other a's. And then this b corresponds to the other b's. The set of all x such that x is a whole number where x is greater than 5. Okay, so you have a roster form, you have a description form, and you have a set builder form, and we're going to be kind of bouncing around between all of them. Now, here's some important set symbols and definitions here. These are very, very important. You're not going to know all of them, and I may even give you some freebies. I won't even charge you for them, okay? I will give you some of them that are helpful. So, for instance, a vertical line, that means such that. The vertical line means such that. Okay. Also, what means such that is kind of like a backwards looking E. Okay. That's also what means such that. This little symbol here means subset of. And then this symbol is probably one of the most important ones. I'll put it in red and I'll circle it for it because that's one of the most important ones. It means intersection of sets or and. So a little upside down U means intersection of sets or and. That's what that means. Okay. Union of sets is also another important one. Just a regular U. It means union of sets or it means or. This is an element of, so the not backwards E, but kind of like a weird looking E. That's an element of or part of or a segment of. This means there exists. So a totally backwards capital letter E. There exists. An upside down A means for all or for every. And then this means an empty set. So this is another one that we're going to be talking about right here, an empty set. Okay? So all of these mean very, very important stuff. And then the last couple ones also are things that we're going to be interested in. Let me kind of move this just a little bit. There we go. So complement of set A. So if I have like apostrophe there, that's a complement of set A. And it's a set because it's a capital letter. And then my last one is just the natural numbers. So if I say a weird looking N, kind of like a bolded N, how I write that is just like this. That's the set of all natural numbers. It's similar to my R right here. This means all real numbers, maybe something you learned in Algebra 2, but all real numbers, okay? All right. So the ones I circled are probably the most important. The other ones are kind of freebie, but those are all symbols that we use in mathematics, especially in set notation. So what is a set? We already went through it. How does it look like? What does it look like? How do I do it? That's what we're going to do right now. M is the set of integers that are greater than or equal to -2 and less than or equal to 1. What will that look like? Greater than or equal to -2 or less than or equal to 1. What will that look like? So the first thing I'm going to do is my first step. I'm going to list it out in a roster form. Okay? List them out in roster form. That's what I want to do. So my first step, roster form. What does it mean to be greater than or equal to -2, but also at the same time less than or equal to 1? Well, it just means -2, -1, 0, and 1. That is my roster form, and that is my final answer. So it's greater than -2, but also included -2, but it's also less than 1, but includes 1. Now let's go to step 2 here. Step 2 is going to be your set builder notation. I'm trying to color code there for you. Set builder notation. So M will equal the set of all x such that what? Well, it is an integer, so x is an integer. So that's what we're going to be writing. But what is this little fancy, what kind of math can we do here? Well, pay very close attention. Look at this. So this is saying x is greater than or equal to -2. And this is saying x is less than or equal to 1. Okay, that's what this is saying right here. How can I put this in a little bit more compact form? If it's and, that means it's an and compound inequality, which means I can actually convert these together and combine them to be x is in between -2 and 1. That is what I'm going to be putting there. And that is exactly what I write right here. So -2 going to 1. And that is going to stop my set builder form. That is my answer. Okay. Now Math Excel will more than likely ask for just this. So anything that I'm underlining in green, that's what you type in Math Excel. So you won't probably even need to write the braces. And then Math Excel will more than likely just want this part. Everything else will kind of be already there for you. So that's not bad, right? And that's how you do it. That's set. So let's go through another example and see if we can do it. So it wants us to first find the roster form, and then wants us to find the set builder form. Christmas colors. Everyone loves Christmas, right? So roster form, what does that look like? P is the set. So P equals the set of natural numbers that are less than 5. What are the natural numbers that are less than 5? Well, first of all, let's list out the natural numbers. The natural numbers, remember I'm going to use this nice little fancy N here that we just learned about. Natural numbers are literally just 1, 2, 3, 4, 5, 6, all the way to infinity. So it's literally just 1 all the way to infinity. Those are natural numbers. So in this case, we want numbers that are less than 5. So x is less than 5. But what we don't want to do is also numbers that are less than 5 but are integers. So I need to restrict this a little bit more. So let's just say from 0 to 5. We could also say this from included and then from 5. We can also say that. 0 is not a natural number, okay? 0 is not a natural number, but 1 is. So we can use something like this. This isn't nearly as restrictive, and this doesn't really include natural numbers, but this does. This includes natural numbers by far. So let's write this down in a roster form. So numbers that are less than 5, but are also natural numbers. So 1, 2, 3, 4, and yeah, we're not going to include 5, right? Because it doesn't say including 5, which is why I don't have an equal to sign right here. So that's it. That's right. That's it. So 2. What's step 2? Well, step 2 is going to be my set builder form. Actually, I want to do this in red here. Step 2, sorry. My set builder form. So it's the P where x, such that x is an element of the natural numbers where x is less than 5, or we can say 1 is in, or x is in between 1 to 5, not included. Now, more than likely, Math Excel will probably just accept this, and that's what you need to write down. But overall, this is your answer in Set Builder, and this is your answer in Roster. Okay? So it's not too bad, right? It just looks scary, but it's not really too bad. So let's continue on here. Let's start going to town. Now it just wants us to write it in Set Builder. So how do I write this in Set Builder? 1, 3, 5, 7, 9, 11, 13, 15. It looks like they're all odds, right? Let's get a inequality to kind of picture and represent this. Okay, what is this? Well, first of all, they're natural numbers. Second of all, they're odd natural numbers. And third of all, it's less than 15. So x is less than 15. So let's write this. So let's just say the set S equals the set of x such that x is in the natural number set, odd, and also less than 15. That is basically our awesome set builder notation. What are you going to write in Math Excel? On Math Excel, they'll mainly ask for this. Mainly ask for that. So don't worry too much about that. All right, we're just going to town here. Let's continue. Now, what's a definition of a subset? A definition of a subset is almost like a sample. So if you think of, since this is statistics, if you think of what we did with populations and samples, guys, a sample is a subset of the population. Okay, so if I have a class here, if I have male and females, females are a subset of my MHP class, right? And so are males. So A is a subset of B, symbolized by this notation, which I told you already. If and only if all elements of set A are also elements of set B. So you can't be a subset in my class if you're not part of the class. So if I say, Sally and Barbara are females in my class, they are a subset of my class because they're both sophomores. They first need to be part of my class. They can't be a subset if they're not part of the actual set of my class. Does that make sense? So let's go on. Note A is a subset of set B if the following two conditions hold. So they need to have two conditions. Number one, A is first and foremost a set. So my class needs to be existent. Okay, does that make sense? It needs to actually be an existing class. Set A cannot be a subset if it is not first a set. Okay, and then two, this condition holds if X is in A, then X is in B. So if Sally and Barbara are in, if Sally and Barbara are actual students in my class, then that, or student like sophomores or females, then that means they can be part of my class. They are in my class. So then let's think about this. Let's think about this right now. Okay. Let's list out, if at all possible, let's list out all the subsets of the given set, so BRX. Okay, let's list them all out. Well, first of all, I can have just the actual subset of B, right? I can also have the subset of R. I can also have the subset of X. Okay? But I can also have, now watch this, the subset of, let me erase, the subset of BRX. Okay, so the whole class itself, this whole set itself can be a subset. I can also have what we call combining subsets, so BR, which means I can have BX, which means I can have XR. Now, can I have RX? Well, yeah, but it's the exact same thing. If I label Barbara slash Sally, or if I do Sally slash Barbara, is it really the same thing? Yeah. If I order Sally first and then Barbara, or if I order Barbara first and then Sally, it means the exact same thing. Now watch this. We are missing one left. We are missing one. We have one left. Think about it. What is another subset? Can I have anyone in the class? Do I have to, if I have this class, my class right here, technically, this is a perfect example for online school because technically I still have a class, even though it's empty. There's no one in this class. So I can still have a set, though it's an empty set. I can still have a classroom, though there's no one in it, which means what I have right now inside, when I'm recording this video, what I have is what we call an empty set, just nothing there. And that's how we label it, with a slash right through the zero, as an empty set. Okay? Even though I'm still teaching, right? I still have a classroom, but it's an empty classroom, an empty set. Okay? So I can have 1, 2, 3, 4, 5, 6, 7, 8 different subsets here. And so that's really, really interesting. So let's move on and talk about complements of sets. What are complements of sets? Well, the complement of a set is a set of all things in the universal set, but not in the given set. And a complement, I usually tell students to think about the weather. If it's 75% chance of raining outside, what's the percent chance of it not raining outside? And you should all say 25%, right? Because that makes the whole universal, the whole 100%. The 25 plus the 75, it makes the whole set, okay? And we denote this by A prime with a comma. The complement of A can also be said as not A. So let's go through this example. Suppose the universal U, the universal set, is 3, 5, 7, 9, 11, 12, 14, 15, and 19. That's the universal set. And set A is 3, 9, 11. What is the not A? What is the complement of A? Okay, so that means the complement of A equals the set of everything that is essentially taken away from the universal set. So if I have these here, I need to take those out of this. So 3, 9, and 11. So that means not A is all of this, what's ever left over. So this is 5, 7, 12, 14, 15, and then 19. This is the complement of A. Set A prime, the complement of A is 5, 7, 12, 14, 15, 19. So I take that out of it. I take the percent chance of it not raining, that 25%, out of the 75%, and then I get the 75%, okay, of it raining. So let's continue on here. Union of sets. Union of sets are a little bit more complicated. We're almost done. We have about 3 or 4 slides left. So the union of sets, what's the definition? Well, the definition here, the union or of sets A and B denoted by A union B, that's what U means, union B contains those elements that are in A or B or perhaps both. Now watch this. Okay, this is what the actual formula looks like, the actual set notation looks like. U, the union, or the universal set rather, of X such that X is an element of A, union with X is an element of B. Or I can say X is an element of A or X is an element of B. So this U actually means or as well. This U means or as well. So an example of this would be if I'm given one set 1, 2, 3 and another set 3, 4, 5, the union of that would be 1, 2, 3, 4, 5. Now, do I repeat that 3 there? No, I don't. Okay? So the union, let's just say you have Sally and Barbara in my class, but only Sally has my wife's class as well, but Barbara doesn't. Then if I wanted to find the union between my class and my wife's class with those students, I would actually include all the students in both sets. So Sally is in both of my sets. That's Sally. Okay? So it basically takes and I would also include Barbara because it's included with everything. Now, if that confuses you, maybe I explained it wrong or explained it kind of roughly, that's okay. It is a confusing topic, I know. So just pay attention when I actually go through an example like this. We want to find D union E, D or E. Now, does that mean am I going to look at F? Of course not. That's just there to confuse you. I really just want to look at D and E. Now watch. When I want to find the union between D and E, that means it's the set. Okay, I want to find essentially everything together. Notice how all of this is shaded. All of it is shaded. It's all shaded, everything. Okay? That means I'm going to shade everything together. So that means 8, 11, 13, I'm taking 10, 11, and 12. And 8. But am I going to repeat the 11 and the 8 here? No, I'm not. So I'm going to take all of this plus the 13. So that means it's 8, 10, 11, 12, and 13. Okay? So it's basically think of like all of it. So I can take all of this and all of that. Think of it like that. Okay? I hope that helps. Now, this is contrasted with what we call the intersection of Okay, the contrasted intersection of sets. The intersection and of sets A and B, denoted by A, upside down U, B, is this. Okay, so let's just say the intersection I equals the set of all x such that x is an element of A and x is an element of B. Now, if you're trying to think about, okay, how can I distinguish between or and? Well, this U is union, and it means or. Upside down means intersect, and it means and. How do I know it means and? Because it looks like an A. Think about it like that. So if that helps you, if it looks like an A, an upside down U, it's and, because that's an A. So that helped me when I kind of went through it and learned it the first time. So the intersection is an empty set. Then if it's an empty set, then A and B are what we call disjoints, but that's usually never the case. So essentially, let's just say I have my class and my wife's class. Let's just say Sally and Barbara are only in my class and not in my wife's class. If that's the case, then they are disjoint. I have disjoint students from my wife's class to my class. Okay? There's no intersection or no overlap. Also, if you guys are big video game players, take something like Halo from Xbox, or Gears of War from Xbox, or even Spider-Man from the PlayStation, the newest Spider-Man that came out a couple years ago, and also God of War. These are exclusive titles, right? These are exclusive titles. So Uncharted is also another exclusive to PlayStation. Since they're exclusive titles here, that means there's no intersection between Xbox and PlayStation, which means they are called disjoint. Okay? So let's just take 1, 2, 3, and then intersection 3, 4, 5. All right? 1, 2, 3, intersection, or and 3, 4, 5. What is the one thing in common? The one thing in common is 3. And this can be demonstrated via a Venn diagram. So if I have A and B, the things that are in common are the things that I'm going to take out and call the intersection. So this is what we call the intersection. I know that's awful. Whatever. Let's continue on. So let's give this example. So let B equal the set of x such that x is an odd whole number less than 10, and C is roster form 2, 4, 7, 8. Find the intersection B between B and C. So first of all, I need to know what B is. Let's put this B in roster form. What does it mean to have odd whole number but less than 10? Okay, odd whole number less than 10. Well, that's just going to be 1, 3, 5, 7, and 9. Those are the odd whole numbers less than 10. Okay? And I want to find the intersection between those. So whole numbers, again, are just integers without fractions. That's what it means. Okay? It could technically be negative numbers, sure, but and we can continue that. Like, it can be definitely negative numbers, but they're not going to have any intersection with C here. What are the ones that actually intersect with C? It seems like there's only one of them, and that is 7. So the intersection is only 7. Even if we did include negative numbers here, it's not going to intersect with C. So this is my final answer, because those are the things that they have in common. Okay? A couple more slides here. Getting into Venn diagrams. So you're starting to see that Venn diagrams are very, very, very important. Or you should start to see that Venn diagrams are very important. Okay? So what is a Venn diagram? Well, first of all, a Venn diagram was created by John Venn in the 1880s. Okay? There are diagrams representing mathematical or logical sets. You did this even in 4th grade, guys. Sets such as circles and closed curves. What we call the universal set. The triangle, the rectangle around it. So common elements of the sets being represented by the areas of overlap among circles. So what will this look like? Well, think about it. I want to make some more room here. Think about this, guys. Let's just say I have all these sets, L, M, N. Now I want to represent the union and the intersection below. Okay, I want to represent the union and intersection below. What will this look like? Well, if I have 3 sets, that means I have to have 3 circles. I'm going to try to draw these circles to the best of my ability. 3 circles, okay? Now, Spider-Man colors because everyone loves Spider-Man. Now, if I say this is L, and this is M, and this is N, let's start doing it. Let's work in between the middle part of the data. So what do they have in common? What is the intersection between all of them? Can you see it? What do you guys think it is? You should say B. So I'm going to cross out B because we're going to use it now. So B is the intersection between all of them right there, B. Okay? Now let's go to the intersection between L and M. So what is common between L and M? Well, there's -1. So I'm going to write -1 here. What else is common between L and M? C. C is common, right? Now let's look at L and N. What's common between L and N? L and N. Anything common between L and N? Well, we have 1, right? So we have 1 that's common between L and N. What about M and N? M and N, what's common between those? 2. So I'll write just 2. All right. Now what we're left with is basically everything that just belongs strictly to L, strictly to M, and strictly to N. So L, what's belonging to just L? A, cow, and pig. So I'm going to write A, and then pig, and then cow. What belongs strictly to M? Just Y and triangle. So Y and then triangle here. And then what about N? 0, horse, duck. So 0, horse, and then duck. That only belongs to N. And there you have it. You have a Venn diagram that you basically use the union and the intersection of sets in order to build it. So let's look at more of a specific example here. I hope that sort of made sense, but let's look at a more specific example after this. Okay, so this is basically just a normal set illustrated. This is set A, this is set B illustrated. Let's try to move this down. Basically representing just tons of numbers. A has all these are the intersection, this is all B, and this is actually the universal set right here. The universal set. And this is actually 9 and 8. So what about this example? Let's try to see if we can do it, and this will be the last example here. So in a survey of, and this will be something that you may see on the test or a quiz, by the way, a survey of students about their favorite sports. The result includes 24 who like tennis, 30 who like football, okay, 11 who like tennis and football, 20 who like tennis and baseball, and 23 who like football and baseball, 8 who like all 3 sports, 3 who like none. All right, what will this look like? This is a lot of stuff. So this is going to be tennis and then football. Well, I have tennis, football, and baseball, so I actually have 3 Venn diagrams. I'm going to just kind of draw. Perfect. Awesome. So let's just say this is tennis. That's tennis. This is football, and this is baseball. It doesn't matter which way it goes. It doesn't matter. Now, let's think about what all of them have in common and work our way out. Okay. So first of all, we know that 8 like all 3 sports. It says it right here. 8 like all 3 sports, right? So I'm actually going to put an 8 right here. 8 likes all 3 sports. And I'm going to work my way from the middle all the way out. So, okay, now let's see who likes just tennis and football. So tennis and football, let's look at that. Where is tennis? 11 like tennis and football. Now, 11 total like tennis and football, right? But we already know that 8 like all 3 sports. So what we need to do for this first one is actually take tennis and hold on. Yeah, let's take tennis intersection with football, and that is just going to be 11 minus what they all have in common, which is 3. So who likes tennis and football? Type a whole number, it is 3. Okay? What about tennis and baseball? Who likes tennis and baseball? 20 like tennis and baseball right here. So for the second one, tennis and baseball, it's going to be 20 minus 8. So 3 like it right here, what I just had, 3. So total, it gives you 11. And then tennis and baseball, this is 20 minus 8, which is going to be 12. Okay, so that means 12 is my answer, and I can put 12 right here. And now together in this whole section here, tennis and baseball is 20, yes, but those who only like tennis and baseball is 12. And that's the key part here. Let's go down to the third one, baseball and football. Who likes baseball and football? So baseball and football, a lot of these numbers are useless, but let's try to find baseball and football. Okay, right here. So 23 like baseball and football, right? So that means 23 minus 8. What's 23 minus 8? That's going to be 15. So how many only like baseball and football? It is 15. And so baseball, football right here, football, baseball, 15. These are the ones that only like it, but there's a total of 8 who like all of the sports. But taken together, football and baseball, there's 23 who like it. So I hope that kind of shows you exactly what Venn diagrams are used for in set notation. And this gives us a springboard when we get into probability. So next week when we get into probability, this is going to be a great thing to utilize the Venn diagrams and the set notation, because we do use them in probability to kind of see what are the sample spaces. So that is the whole lesson. We have finished our first full week of statistics, Unit P, descriptive statistics, kind of like a prerequisite unit. Let's see what we learned. So we learned how to understand set notation in relation to complements, unions, and intersections. We learned what Venn diagrams are and how they connect to set notation. All right, now the last thing that we have literally is just this Desmos activity. So I'm going to go through it really quick, but most of it, I'm just going to chalk it up to you guys to complete by Friday at 4 p.m. Make sure you complete it by Friday, 4 p.m. Okay? So go ahead and go to student.desmos right now. Go to this, type in this code, go to student.desmos and type in this code. All right. If you are paying attention to the videos, you should be doing the Desmos activities. Fantastic. Let's go on to it. So analyze data with box plots. Now this is kind of a springboard off of what we did yesterday with regards to the 2.5 measures of position. But you're really just going to go through these, and these are kind of fun because you can kind of move these around. Okay, you can you can move these around and see how they can be moved around. And now notice what's happening here. You see what's happening? When I move this data sets, my quartiles actually change. So you're going to just describe how the two representations of data give you different information. This is a box plot up here, okay, or a dot plot. Sorry, this is a dot plot right here, but this is a box plot. So down below is a box plot, just a box and whisker graphs, and this is a dot plot right here. So how do the two data sets kind of help you? Like, how do they essentially give you the data? What if I wanted to move this all the way over here, right? Or move this all the way over here? What happens? How do they relate to each other? That's what I want you to kind of write here. Try, and I do go through these, so this is worth a grade, so try to your best possible phraseology as you can to write what you need to write there. So This is the definition of box plot. We already went through this, so that's great. And then observe. This is probably the last one I'm going to go through, guys, and then the rest will be yours. Okay, just do the best you can. It is participation, but I really want you to try to look at different, not just box plots, but dot plots and how they relate to each other. And also, this gets you familiar with Desmos. This gets you familiar with Desmos because you're going to be using it a lot. So I'll go through this one. Drag the blue points. Describe how changing the data set affects the box plot. So if I move these points, how does that change? So let's just say I move a ton of data here, a lot of data. What happens here? The more data I move, let's just say to the right, the more this box changes. So if you have most of the data kind of compiled in the middle here, then you will have a box that's compiled in the middle. And that's what you should write. If you have a lot of data that's compiled in the middle, you will have a box that's also compiled slightly in the middle. Notice that. It's all in the middle. But if you spread these points out, trying to spread these points out, then the larger your box will be. So the more spread your dots are, the more spread your box is. The more compact your dots are, the more compact your box is. And that's how changing the data set affects the box plot. And that's really what you're going to be doing for the rest of this activity. You're going to be kind of describing what it is, how to find even this one, how to find the min, the Q1, the median, the Q3, and you should know how to do that. Okay, you should be able to find what these are just by touching them. Okay, so try your very best. If you have any questions on this, please, please, please let me know. But again, go to student.desmos.com. This is it right here. Get logged in, make your own account, and finish that for me by Friday at 4 p.m. All right, and this is your Desmos activity. Again, make sure, I'll probably put the code right here, so just so that you know. All right, make sure you finish your Cornell notes. It is going to be Friday. I know I said in the template here, let me go here real quick. The template, I said that you don't have to do the box plot until Friday, and that's fine. If you're watching this on Thursday, if you want to do the box plot tomorrow, Friday, that's cool too. But just remember all of these reminders. So you have focus note checks, a check on the set notation, the lesson that we literally just finished, the set notation Venn diagram. You have a focus note check on that. Make sure you go to the classwork page for submission details because you need to submit that. You need to take pictures and submit it. I will be grading it accordingly. Okay, it needs a summary, needs a heading, needs the essential question, and so forth. Make sure you complete your Math Excel orientation and login information. That's on Google Classroom, but it's also going to be, on Math Excel. That's due also Friday by 4 p.m. Honors contracts. I don't know if any of you are interested in honors still, but remember, you have to have a parent or guardian send me an email. Your signed syllabus. I don't know how many of you still need to do that, but your acknowledgement form, go to the very first announcement on the stream page or go to the classwork page at the very, very top where it says syllabus. Click on that, click on the acknowledgement form and fill that out. That was due Wednesday, 8/5. So if you're watching this video and you have yet to do that, and it's Thursday or Friday, it is past due and it is now late. Okay, it is late. I will take off 10%. And just a general reminder that all assignments, every Math Excel assignment, all Math Excel quizzes, you don't have any Math Excel quizzes right now, but you will in next week. But all Math Excel assignments, the Desmos activities, the notes, the syllabus acknowledgement form, all of that is due Friday by 4 p.m. So this was a rather strange week, guys, because this week was just kind of totally different for all of us. Not just different for teachers here, but also different for just you guys just staying at home, not really interacting with this. So if you have any questions, again, I can't urge you enough to email me, come onto the Google Meets link. Don't forget to check in with me every day. Remember, attendance is an actual thing. I grade you on attendance. Don't forget to do the Math Excel homeworks because I grade you on participation. I know it's tough, but we can get through it. That's it. So I will literally see you on Monday, hopefully at 1:30. If you have because of the Meet link. If you have any maybe tutoring that you need to get through, then just let me know, and then we can set up a time on Friday between 10 a.m. to 12 p.m. But guys, until next time, it's been a blast. Please make good choices. I'll see you later, stats.